Hey guys, welcome. In this tutorial, I'm going to demonstrate an end-to-end deployment of a chatbot that uses the open source ChromaDB as a vector store in order to store the embeddings from a PDF file. This is going to be a typical RAG or grounding use case on Google Cloud Platform, where the application itself will be deployed on Cloud Run, which is a GCP offering for containerized applications. Now, in the process of development, you will see how to make use of the basic concepts such as chunking, embedding, and using memory in a chatbot, which is all part of the LangChain framework. Now, you could use ChatGPT or Gemini for this tutorial. I will leave that up to you. And Streamlit is going to be the front end framework that will render the chatbot UI. Now, this is a 100% hands on tutorial. So, I'm assuming you are comfortable with Python since that's going to be the scripting language. You must have an active GCP account, a trial one will suffice, and of course, you must be aware of the basic concepts in the world of LLM and AI, which are quite popular these days. On this note, let's jump right in. Now, for the code execution, I'll be executing the entire code for this tutorial inside my GCP account in a Jupyter notebook under Vertex AI. You can also do it from your local system, but I want to avoid doing it from my local system because you end up installing a lot of libraries such as LangChain and Chroma and so forth, which I'm trying to avoid. But if you don't want to do it on Google Cloud, it's absolutely fine to do it from your local system as long as you have the right modules installed and the configuration set up. So if you're going to follow all the steps in this tutorial, head over to your GCP account and from the search bar type Vertex AI. And once you're here, just click on Workbench. Now in here, click on Create New. Give your instance a name if you want, or leave it to the default one. Don't click on Create yet, just click on Advanced Options. Select Machine Type, and here we will select the smallest machine available, which is E2 Standard 2 that comes with 2 virtual cores and 8 gigs of memory, which should be more than enough for us to be able to perform everything in this tutorial. Also, make sure to check the box under idle shutdown. This will help you avoid unnecessary costs. You can set the time to 15 minutes or 20 minutes, whatever you want. This would basically mean if your workbench is idle for 15 minutes, then it's going to automatically shut down. And then just click on create. I'm not going to be doing this because I already have a workbench created. For now, I'm going to click on cancel. Now, once you have a workbench up and running, you should see it here. Give it a couple of minutes, and once it's ready, you can just click on Open Jupyter Lab. All right, so once you have set up your workbench on Vertex AI, you can just click on the workbench and spin up your Jupyter kernel. Start by importing the IPython notebook, which is called Chroma Basics, which you can find inside my GitHub repository for this tutorial. Also, make sure to download the PDF that we're going to be using as the underlying data. It's called taxguidance.pdf, and it's a random PDF that I've downloaded from the internet. It contains information for senior citizens pertaining to tax payments. Now, you can feel free to use any PDF of your choice. You don't necessarily have to use this one. So that's the PDF that you need to upload inside a folder called data. So create a folder inside your current working directory and upload the PDF inside of it. Now, once you open the IPython notebook, you will see the very first code block contains a pip install command, which is where you'll be installing all the necessary modules for this tutorial. So uncomment this line and execute this code block. It's going to take a while, so be patient, but make sure you complete the installation and not close the kernel before that happens. Once the installation is done, you can then click on kernel and restart it. So that's the necessary modules for this tutorial. We then start by the typical import statements where you import the necessary libraries. We need LangChain, a module called create retrieval chain. We also import create stuff documents chain, which I'll talk about shortly. We need all the document loaders since we're going to be working with unstructured PDF file. We need the prompt template from LangChain, character text splitter in order to split the data inside of PDF. We're importing Chroma. Pay attention, we have installed Chroma here, which is the version 0.4.24. We import Vertex AI and Vertex AI embeddings. Now, this is the part where you can use any embedding model or LLM of your choice. Since I'm going to be working with everything offered by GCP, which is the LLM Gemini 1.5 Pro, and also the text embedding Gecko, which is a GCP offering. I have to import these two libraries. So this is the project ID. The location where I'm executing this workbench is US Central 1. Index path is where you have uploaded your PDF file, which is inside the data folder, which is right here. And persist path. Now the persist path is basically where Chroma will persist the vector embeddings or the data. We don't need to create this folder. It'll be automatically created when we execute the relevant code block. So let's start by executing this code block. Next, you define a function called get split documents, and all this function does is splits the document inside of the index path and returns the number of splits, right? And you can see this is where we're using unstructured PDF loader in case it's a PDF file. Otherwise, we'll be using the text loader. We're also using the character text splitter in order to split the PDF into multiple chunks, and I'm giving random numbers here. So you can see the chunk size is 8192 and the overlap is 128. Now, when it comes to production scenarios, you must have a fair idea of how to work with chunk size and overlap size. But for the sake of demonstration, I'm using random numbers here, which should work. You define the batch size of 5, and next we create the embeddings. So let's run this code block. Let's get to the next one. So here we invoke get split documents, which pretty much splits your PDF files. And once the splitting is done, we then ingest the split into the ChromaDB, which is where we invoke the from documents method, and we pass the splits, the embeddings, and the persistent path, right? Now, depending on the version of ChromaDB you are using, you might or might not have to use the last command which I have commented out, which is called db.persist. In the latest versions of Chroma, it automatically persists the data. But if you're using the earlier versions of ChromaDB, then you might have to uncomment this line and execute db.persist command. So since I'm running Chroma version 0.4.24, I'm not going to be manually invoking this command, which is db.persist. So let's run this code block now. You can see it detects the file name inside the data directory. It's called taxguidance.pdf. And very soon you should see a new folder created here. Right, there's an error. Let me actually change the file name. I think it's because I had executed this code block before. So let me create a new folder, and I'm going to copy this file and paste the PDF inside of it. So let's run the code blocks again. All right, so this one worked. Let's go back, and you can see the folder persistentdb has been created, and you will see chroma.sqlite 3 folder and also a folder with an alphanumeric name. So this is basically your data being persisted. All right, so everything works fine so far. Next, we define our LLM. Now, like I mentioned before, you can use any LLM of your choice. You can use ChatGPT, you can use Llama. I'm using Vertex AI's Gemini 1.5 Pro, which is why I'm invoking the method Vertex AI by passing the model to it. And these are the different parameters that you typically use to configure any LLM. You have the max output tokens, the temperature, top P, top K, and verbose is set to true. So once you define the LLM, you then define a retriever object. Now, a retriever is similar to a cursor, conceptually speaking. If you come from a software engineering background, you might have used cursors in your traditional relational databases, right? So a retriever can be thought of to be similar to a cursor. And this is where we actually use db dot as a retriever. Now the db is nothing but an object of ChromaDB, all right? And using that, you create the retriever. The search type is similarity, since I'm going to be demonstrating similarity search. And the number of similar results to be returned or neighbors is set to 3. You can play around with these values if you want. Then we define our template, which is where I'm saying you're a helpful AI assistant. You're tasked to answer the question below, so on and so forth. You pass the context, uh, which is the context that will be passed dynamically. The question, which is your user input query. And you also put an instruction here by saying if you cannot find an answer, ask the user to rephrase the question. You can, depending on the context and the nature of the chatbot you're building, you must define appropriate instructions more clearly. So that's your template, and we define the template or the prompt by using prompt template dot from template method. Let's run this code block. All right, so the prompt is defined. Next, we use two functions. One is create stub documents chain, and the second one is create a retrieval chain. Now, if you look at the official documentation of LangChain, you will see the definitions of both these methods that I'm invoking, which is part of the LangChain library. So create stub documents chain basically takes a list of documents and formats them all into a single prompt, which is then passed as a prompt to an LLM. And if you come back, which is exactly what we're doing. So you have the LLM uh, and the prompt, which has been defined above. You pass both of them as arguments to this method, which is create stub documents chain, and you create an object. And then you invoke create a retrieval chain, which is where you pass the retriever and the object created above. Now, if you look at create retrieval chain in the official documentation, which is right here, it says this chain takes in a user inquiry, which is then passed to the retriever in order to fetch the relevant documents or results. So, which is why we pass the retriever object here along with the object created above from create stuff change stuff documents chain. Let's go ahead and execute this code block. We're almost done. So once you have the retrieval chain, all you need to do is invoke it. And this is where you pass the user input. So here I'm saying, tell me about figuring the EIC. Now, this is a random question which I know has an answer inside the PDF. So if I just run this, then run the last block as well, you will see you get an answer. Now you can try out different questions. Feel free to ask the LLM anything you want and just look at the answers if they make sense or not. Now we get to the last bit of this implementation. So now that we know the data inside of ChromaDB has been persisted inside of this folder PersistentDB, in order to be able to use this inside an application, be it a chatbot or be it a microservice, doesn't really matter. If you want to use a persisted data store, you must store it somewhere, right? We are running a Vertex AI Workbench, which is only used for development purposes, right? So now what that means is you must move the data inside of PersistentDB to some other place. Since I'm talking about GCP, we have to store this inside a GCS bucket, which is exactly what is happening inside the last code block. Now, the last code block has absolutely nothing to do with LLM or AI or anything of that sort. It's just pure and simple Python. I'm importing Google Cloud Storage. I'm importing OS. This is my bucket name where I need to persist this data inside the folder PersistentDB. It's going to be inside a folder called Chroma, which will be automatically created. The local persist part is nothing but this folder name PersistentDB, and that's it. There's a function called upload directory to GCS. It does not have to be a function. You can actually execute the lines inside this function directly, and that's pretty much it. So let's run this code block. All right, it says the files have been uploaded to the GCS bucket. So if you go back and do a quick refresh, there you go. So you can see this is the bucket. This is the folder called Chroma, which is what I had defined as the folder name. And these are the two folders, one file and one folder, which is what is inside of PersistingDB. All right, so far we have created embeddings out of a PDF file and stored them inside a ChromaDB. We also moved the ChromaDB from the working directory of our Workbench to a GCS bucket. Now, when it comes to building LLM applications, you're typically talking about a chatbot application or a microservice. Now, assume you have developed a chatbot application using Streamlit and you are going to deploy it on Cloud Run. Now, the objective of this application is to accept user input queries and look for answers in the ChromaDB uh, in order to answer the user queries, right? So that's the objective of this chatbot. And assume there's a user input coming in from the UI. Now, what this chatbot is going to do is basically look for the answers for that specific question inside the ChromaDB, which has been persisted inside our GCS bucket. If you remember, we have a folder called Chroma, inside of which we have the ChromaDB files, right? So this is the file which contains the embeddings, or basically the answers to the questions. Now, in a production environment, it does not really make a lot of sense in terms of efficiency and performance for the chatbot to do a lookup on files residing in a GCS bucket. So, what we're going to do is basically at runtime or at the time of deployment, we're going to write the backend code for our chatbot application in such a way that the second it's deployed, it's going to download the persisted data from GCS bucket into its local container. So if we open up the next IPython notebook, which is called Chroma Inference, that's pretty much what is happening. So we import the necessary modules from LangChain that we have already installed. This is the bucket name where I have stored my ChromaDB files inside the folder Chroma. This is the local persist path, and I'm calling it local underscore ChromaDB. You can call it whatever you want. So now what's happening is basically there's a function called download directory from GCS. All this does is downloads this data, which is inside Chroma folder, all your ChromaDB files, into the current working directory. And this is going to be the backend code for our Streamlit application, which we will deploy inside of Cloud Run. All right. So that's what the function does. And once downloaded, I'm using the exact same embedding model that I had used previously so that the user input queries can be converted into embeddings in order to do a lookup inside the vector data store, which is ChromaDB, right? It's the same number of batch size, which is set to 5. So I create embeddings from the user input, and this is where I create a retriever. So you can see I'm creating a DB object using Chroma, and the persist directory is the local path, all right, which is going to be local underscore ChromaDB. Now you don't see the folder here, but as soon as I execute this code block, you will see the ChromaDB files from GCS will be downloaded inside the current working directory, which is exactly what is going to happen inside the Cloud Run application as well. We then create a retrieval object similar to before, and then this is your LangChain template. We use prompt template for that, and the rest is exactly the same as we did previously. So let's run the code block, the first one. All right, so it says downloaded, and there you go. So we just basically downloaded the file back to our Workbench, and I did this just to demonstrate what will happen inside the Cloud Run application when we run this. Now my question is, tell me something about EIC, which is the exact same question, but here the lookup is happening inside the vector embeddings stored inside local underscore ChromaDB. So let's run this. Now let's see the response. There you go. So that's your response, and this is going to be the backend code for our Cloud Run application, which is going to be deployed in Streamlit, like I mentioned before. Now let's open up the Cloud Run directory, which you can again download from the GitHub repository for this tutorial. And inside of that, you will see app.py and the Docker file, which are two of the most important files for this deployment. And app.py is basically a simple Python application which contains the backend that we had executed earlier inside the Inference notebook. So for the UI, like I mentioned, I'm using Streamlit, and we import all the other necessary libraries that we are aware of. This is my bucket name from where the ChromaDB files will be downloaded inside the Cloud Run container where this application will be running. So make sure to change the name of the bucket here as per that of yours. The local persist path, I'm calling it local underscore ChromaDB. The ChromaDB files get downloaded to the local container, and that's pretty much all that's happening. You create a retriever. I'm also using memory in order to retain the chat history in a typical chatbot conversation, for which I'm making use of conversation buffer memory, which is part of LangChain. It's quite simple. You can go through the code. It's easy to implement. And here I've given two options. You can either use ChatGPT as your LLM model. Make sure to change the API key. This is my API key. Uh, or you can even use Gemini. All right. So if you're using the trial version of your GCP account, you might run into quota issues because there's a very low threshold on the number of calls you can make while using any of the LLM offerings on GCP. So in case that does not work, you can use ChatGPT. This is the conversational retrieval. Like I mentioned, I'm using memory in order to refer to the previous conversation. This is a basic conversational memory which is inbuilt inside of LangChain. And that's pretty much it. So that's your app.py. Inside the Docker file, I'm using the base version of Python, which is 3.9. I install all the necessary modules which are inside of requirements.txt, and I'm running my Streamlit app on port 8080. All right. Now, if you open up the terminal, I've already deployed this application inside Cloud Run. So the very first thing that you must do once you open up your terminal is to execute the gcloud auth login command and hit enter. So this will authenticate your local terminal to interact with your GCP account. Once that is done, you set the project ID in context by saying gcloud config set project followed by your project ID. Don't type project ID, but actually you can get the project ID from here. Once that is done, open up deploy-commands.sh and just copy the code here and run this. Now this is going to deploy the Streamlit application, which is defined inside of app.py as a Cloud Run service, right? It's going to take a while, maybe 5 to 7 minutes. So just be patient and let the application deploy. Once that is done, you can just go back to your GCP console and type Cloud Run. You should see the application info-chatbot here. So just click on it and you should see the application URL here. So click on the URL. Now this is going to open up the chatbot using which you can interact with the data which is stored inside your ChromaDB. So I'm using the exact same question, which is called tell me something about figuring the EIC. And there you go. I believe I'm using ChatGPT if I'm not mistaken. Yep. So you can see in conversational retrieval object, I'm passing LLM underscore OpenAI object, which is basically ChatGPT version 4. You can try with Gemini as well and see if there's any difference in terms of accuracy. So that was that for this tutorial. I hope you guys enjoyed it. Make sure to like and subscribe for more videos. Thanks a lot for watching.